I'm going to be talking about Airflow tonight. Airflow is a workflow engine. It is open source. It's been working at Airbnb in production for a good 9 months, 10 months or so. It is, definitely one of the best workflow engines out there, as far as I know, or the best one that I have made. Uh, so that is the statement here. The one-liner for Airflow is, it is an open source platform to programmatically author, schedule, and monitor workflows. Workflows, you could interchangeably call it data pipelines. It is a batch processing engine with dependency management. In a lot of ways, this used to be called ETL tools too. There is a focus in Airflow on programmatically authoring, so that's really important here. And we think at Airbnb, and like one of my convictions is that when we manage workflows as code, it's easier to build things that are more dynamic and things that that are easier to review and to manage in general. So I was at Facebook before, where I was very involved building complicated things on top of something called Data Swarm, and also contributing to Data Swarm, which is their workflow engine. And coming out of Facebook, I was really looking for something much like Data Swarm that would have like this level of all the power that Data Swarm had, and there was nothing out there. We reviewed the different tools that were out there, and we had people from LinkedIn, people from Yahoo, and from different places, and they were all saying like, don't use the workflow engine that we have built there. We need to build a new one. So we agreed on that. I was at Yahoo before, so that was like 2007 to 9 or so. So that was kind of the birth of Hadoop at the time. So kind of an interesting fact about Hadoop is that it really was not working very well back then. It's still not working great, but it works pretty good now. And like back then, I just had no idea that I would become what it is now, right? So yeah, I was Yahoo at that time, and then at Ubisoft, I learned kind of all the more classical data warehousing, business intelligence stuff. So throughout the years, I've seen kind of analytics really evolve from business intelligence and the tool set of ETL that are now becoming more like data engineering type of tool sets. Something interesting about what the work that I was doing at Facebook was really capitalizing on the fact that we had a very dynamic workflow engine, right? So building pipelines that are writing code, writing machines that build pipelines dynamically. So areas like analysis automation, analytics as a service, all sorts of like computation framework stuff, doing stuff dynamically like core analysis, growth and engagement computation. So stuff that you can only do if you have a very dynamic workflow engine and a big cluster of machine, which they do have at Facebook. Cool, so the problem statement, I think if you're here, you're familiar with the problem statement, which is, companies have a lot of employees that work with data. We have very powerful clusters of machines, and we need to write batch processes. So many of us, day job is to generate, batch process to organize data. And we're all, sought after, well paid, and it just makes sense to have really good productivity tools for people who do that. And like data engineering, data analytics is super important in modern companies. So it's important to have really good tools to support that, to make all of us more efficient, less frustrated, happier in general. So we have more time to do what we like to do, which might not be data engineering. So here's a slide about like what's wrong with the kind of the classic approach or the naive approach. The naive approach is if you don't have any tools, what do you do, right? So you write batch jobs on your clusters, and then you schedule them, probably using something like cron. And even if you have a few people working with data, writing batch job, it won't take very long before you have a mountain of scripts and processes and dependencies, and very quickly you can get tangled into not knowing what's going on, what ran, what did not run, who's the owner of this, on which machine did it run, did it complete, why is the data not there? So these are all the classic problems that companies that have grown too fast in terms of data without thinking about tooling will see, right? And even companies that are pretty serious about data that have good tools still have some of these problems. So the tooling is very important there. And Airflow is trying to address like a lot of these things. So the genesis, I talked a little bit about that. So why did we decide to build a workflow engine in a world where there's like a bunch of vendor tools? There's Uzi, there's Azkaban, there's Luigi. So I had very high hopes, and I wanted to do things that could only be done, with a tool like DataSwarm at Facebook. And we saw this at Airbnb as an opportunity to give back, right? So at some point, you use all these open source packages, and you're like, how do we contribute to this? And we saw this kind of whole vortex where like maybe we can create something really nice and share back with the community. And it's always good to give back, and it's a good way to for recruiting and just for be a beacon in the world of data. So those are the things that we do with, or some of the things that we do with Airflow at Airbnb. So batch processing, workflows, you can do pretty much anything. But at the center of it all, and what justified in the first place building a workflow engine is data warehousing. So data warehousing is pretty static. It's very important. We need to organize our data, cleanse our data, get it in a place where it is well structured, where we have good naming conventions, where in this chaotic world of data, having some anchor points where people can latch onto and make sense out of all this data without having to query directly logs or database scrapes. So data warehousing is at the center of it all. Then like deeper analytics, like growth analytics, engagement analytics, search ranking, experimentation is a very big thing. So I'll try to show what our workflows look like for experimentation, but this is an area where we generate pipelines dynamically at Airbnb. So for each experiment, we instantiate a pipeline that waits for specific metrics to land in a warehouse and build all the analytics for experimentation and A/B testing. Anomaly detection, sessionization, so all the classic things that most companies do using Hadoop, right? It's just we organize it in these Airflow workflows. So scale. So generally, like when you see a Facebook engineer leaving Facebook and going to some other company to build something, scale, is like one of the primary concerns. So you probably should not worry about scale if you use Airflow, right? Because it's been built to scale. So right now we actually it says 6 nodes. I think that's an old slide. We have a lot more. I think we have probably like 14 boxes that run as Airflow workers. We run about 8,000 tasks a day. We have a lot of people internally, so the whole data engineering team, some people in data science, people in engineering, people in growth and engagement are writing their own workflows. So 15 companies as of today have put their names on our GitHub readme.md file saying that they use Airflow. In reality, I think it's probably closer to 30, 40 companies using Airflow in production, and then a lot of people kind of playing with it, trying to figure out what they're going to do with all this data and all their scripts. We're not concerned about any bottlenecks, right? Like the current architecture will scale beyond our needs as far as we know. I think my first slide was like you add an orchestra director on there. So Airflow does not do that much work. It can take on some work, but it mostly orchestrates all these other systems. So you say, run this pig job, run this hive job, run this bash script, this Python script. But in a lot of cases, the computation is done in the big cluster of machines specialized to do that. So the bottlenecks is like, it's more like managing metadata really, right? Airflow is just like trigger these jobs, look at state, look at the pipeline definition and trigger things. Design choices. So I'm a Python person. I should probably be presenting at PyData soon because Airflow is all built in Python from front end to back end to pipeline authoring is done in a Python DSL or by instantiating Python classes. So so it's nice to have something very cohesive that's all Python, and that makes for sharing objects and constructs across the different layers of the code very nice. A focus on authoring. So I'm a pipeline writer, right? So I really put a lot of thoughts into authoring a pipeline and how to define your parameters and how you define DAG level or workflow level parameters, task level parameters, being able to override these defaults, and just making the experience of writing a pipeline as compact and as simple as possible. So an Airflow pipeline will just be like as small as it needs to be to express what it needs to do. It's programmatic, so I talked about this already. So it's very important to be able to dynamically generate pipeline, because then you can elevate yourself above someone that writes pipeline to someone that writes code that can instantiate pipelines. And that matters when you do things like building pipelines around an A/B testing framework. If you do email targeting, right, people could just define some rules, and then these rules they can put in YAML, or maybe they can define their rules in a UI, and then these rules can be parsed to build pipelines dynamically. So we can commoditize the work of data engineers and scale it up at a higher level. So other examples of that, so at Facebook I built a cohort analysis framework, and the way that worked is in a UI you could define segmentation queries as queries that would return a set of user IDs, and then you could define an arbitrary set of cohorts. Then we could use these metric repositories that we had at Facebook. Metric repository being tables. If you simplify it, it's simply timestamp, user ID, metric, and metric value. And we're able to say, this cohort analysis framework, someone can go in a UI and say, I want to use these 6 cohorts, I want to focus on these 12 metrics, and I'm interested in these demographics, and based on that, generate a pipeline for me, prepare a cube, prepare a data set, put it in the database where I can interact with it, and all of this is done dynamically from a UI. So the level of abstraction there is, I'm doing a cohort analysis. What are my cohorts? What are my metrics? What are my demographics? Which is the right level of abstraction that people, that analysts are interested in. And then, as opposed to common ETL tools, the level of abstraction that they expose is drag and drop arbitrary script on a screen. With Airflow, we can build an application that can abstract things as complex as cohort analysis. Anyways, that was a kind of a tangent here. But I think it's really important, the whole programmatic approach to data engineering, right? Being able to write applications that generate pipelines. That's where the power, that's where I feel like the future of data engineering is going towards. All right, so these are new slides. So if people saw the Hadoop Summit talk I gave, there's a few new slides. And tonight it was called, there was something about best practices using Airflow, so I think I have an extra slide on that. Since that talk, there's been a lot of new features added to Airflow. Airflow is it's a project that started a year ago, and it's growing extremely fast. So there's, every few months, there's tons of PR. There's a version coming out pretty much every month with major features. So this slide is to show what are the things that everyone needs if they're going to author batch jobs and write some workflows, right? If you don't have this, you should probably not even be writing a batch job. You should just work on your workflow engine, because you're going to get tangled in your mess very quickly. So, so here, what do you need if you're authoring batch jobs and you need to orchestrate them? So basic dependency management, clarity on status, did this job run or fail, or how long did it take to run? Scheduling, right? Most pipelines run on a schedule. So easy access to logs. So when I started at Airbnb, it was like impossible to get to our logs. The stuff would run in Mesos, and logs would be very ephemeral. And stuff would fail. You're not sure if it fails. If it fails, you don't have access to your logs, or it takes you, like 6 minutes to SSH, figure out which box you need to SSH in. And then if you're lucky, the log is still there. And this clarity on logs is vital. If you don't have that, you can't do anything else, right? So parameterized retry. So stuff fails, and systems go down, and it's nice when it can self-heal every once in a while. So parameterized retry is pretty vital, and notification when something fails, it should probably send you an email. So if you don't have this, go figure this out, because you can't do data engineering without a workflow engine that does these things. So the cron approach does not necessarily do that unless you build tooling on top of it. So that's so the features here. I was trying to capture some of the more advanced features that you'll want as a data engineer, as you author more pipelines, and as you schedule more jobs, as your company gets bigger. And I crammed a lot of stuff into this slide, so I think I'm going to take the time to go through it. And I think the features kind of it fits well with the drawing. So the drawing shows like a lot more tools than you need, and this is kind of what's going on with Airflow too. So this definitely a workflow engine you can grow into. You might not need all of these, but eventually someone in your team is going to need some of these features. It's super nice to have them there the day that you need these features. So the first thing is scaling out while preserving these things, right? So being able to pop, one or two more machines and still having access to your logs and still having everything working, still having centralized metadata. So you'll need more than one box at some point, and you'd better have a workflow engine that works, because your main focus, the week where you're going to need that extra box, is not going to be to improve the workflow engine. So queues. So here I should have sorted all these features in more from the most useful to the less useful, probably, though it's pretty subjective. So queues in Airflow, and here it's kind of generic too. It's like features that a workflow engine might or might not have, but all of these Airflow has. So queues is a way to target specific workers when you instantiate a job. So in Airflow, anytime you instantiate an operator, you create a task for your workflow, you can target a queue. And this queue, for us, the way we use it is we have a silver and a gold Hadoop cluster, and we might want to run stuff on gold or stuff on silver, so we can target different clusters this way. And then we have specialized workers for R, so data scientists like to do very crazy stuff with R. They like to use Airflow to scale out their R jobs. So we have kind of a sandbox there. They can target these boxes and take them down if they want without affecting the other Airflow workers. Another use case is we have a Spark cluster, and we want to trigger a Spark job, and these jobs have the assumption that certain Spark library live there, so we can target specific worker for specific queues. Pools are a way to limit concurrency and prioritize. So classic use case is like, how many people use Redshift here? So Redshift doesn't take concurrency all that well, right? So maybe you want to run like 3, 4, 6 Redshift ETL jobs at once, but you might have hundreds of jobs you want to run against Redshift, but not at the same time. So pools, you can say, I'm going to create a Redshift pool with 4 slots, and then you can prioritize your job by parameterizing it to say, setting a priority weight for individual tasks. And one cool thing with that feature is I wrote it in a way that when it's time to prioritize queued task, it will look for the summation of the subtree in that DAG. So that means that if you have a very complex DAG, and I should probably have one, but like one leaf that is super high priority, and you put like a priority weight of 1,000, all of the parents, the whole path to that job, will be factored in, since we sum the priority weight of the subtree. Complex dependency rules, right? So you need to do branching, joining, having sub workflows. So you zooming in into a workflow a workflow DAG. So you can do that. Hackability. So that's one really great thing with open source is like stuff comes hackable out of the box. So we made a bunch of parts of Airflow very extensible, so you can create your own constructs, and you can derive the classes, and you can change the scheduler. You can create your own executors. There's kind of no limit there since it's open source and it's well designed to be hackable and extended. SLA monitoring, so you'll run into that at some point where if some job is not done by 9 a.m., like someone needs to know about it. So you can do that very easily in Airflow. So you'll get an email for a specific DAG that says, here's the list of jobs that were not done at the time where they should have been done. Easily alter states. So the state can become really complex. So you have a lot of jobs, you have a lot of dependencies, you have a lot of owners, and you need sometimes to say everything from this date on, everything downstream of this task should be rerun. And you need to be able to perform these surgeries without having to do too much work, right? So in Airflow, you can do that from the UI, from the CLI, but it's really important to say, like, for this date range, mark these tasks as successful, or all the tasks that match a certain regex, or all the tasks that are downstream of something that failed, put a false positive or put a false negative in place for altering the state. Clarity around ownership and versioning. Data profiling is something that arguably should not be part of your workflow engine, but it's part of the tooling that a data engineer needs for sure. So being able to visualize things and run queries and do basic interaction with data is also part of Airflow. Hopefully I have time to show that in the demo. Templating, so how do you get parameters into your scripts, right? And how do you get code logic into a batch? So say you have a bash script or a Python script or a Hive job, you want to parameterize certain things, maybe the table name, so that you can run something in dev or in prod by switching the set of tables that are referenced. You might want to call certain macros in your templates, like what is the latest partition for my dimension table. So all of these things come with templating, and that's a very powerful thing that I'll try to demonstrate. Centralized connection management, so that's like if you think of like the first ETL tool you work with, whatever it might be, even if it was like the Microsoft one, I think you're one of these guys. It's like, sorry to putting you on the spot on that, but like there's always been a connection vault where you say, here are my connections and here are my host names and login and password, and you put that somewhere. Then you can only reference your connections in your pipeline, so you don't have to think about hard coding your connection strings while you're writing your pipeline. So that's pretty important. Plugins, so Airflow's got a plugin architecture. So since we've got all this library, this tooling, we know how to connect to all your databases. We have a web UI running on a bunch of servers. We have a way to push workload onto workers. It makes sense to make that available to developers so that people can write their own plugin. So some examples of that, Airflow ships with one that's a Hive metadata browser. So in the UI, you can go and browse your schemas in Hive, and you can browse your tables and see sample data and the DDL and all that good stuff. And then built-in integration, so that's one thing that other ETL tools out there don't necessarily ship with. So if you use Pinball or Luigi, you might get more or less connectors to different things. But with Airflow, we made it very extensible so that we have all, at first it shipped with things that were really tightly coupled with the AirBnB stack, right? So everything around Hive, Presto, Hadoop, HDFS, S3, like these we care a lot about at Airbnb, and we built all the operators around that. So sensors, job, and then like tooling to move data from MySQL to Hive, and backwards. So Airflow comes fully loaded with pretty much a connection to the Hadoop stack. But like people have added all sorts of extra connectors now. So, connection to Oracle and SQLite and Vertica and Postgres and arbitrary databases that people are interested in. So that's pretty important. I think I was talking with someone that was telling me that they use Pinball, but they had to write all this tooling to interface with these extra systems because it didn't ship with it. So they have really a workflow engine that doesn't know how to talk to anything, but you need to write this part if it's not provided. Okay, so this is going to get a little bit heavy. So that was my attempt at trying to bring best practices. It was in the title for the talk, and there's a few things that come very naturally in Airflow in the way that it's designed that match some best practices on how you write ETLs in pipeline. So immutable data set. So a lot of people don't get that. So what does that mean? So say you have a set of files that generate other files, or you have a set of Hive partitions, like all your tables are partitioned in Snapshot by day. It's really important to know that your partitions are immutable. If you rerun the same job with the same parameters, you're going to use the same sources and get to the same destination and have a reproducible result. An example of that being broken is if your dimension tables you join to, but they constantly evolve, you don't snapshot them, you can rerun the same job from 3 days ago with a non-immutable partition. It's been mutated since you ran it and you get different results. So if I had a whiteboard, I would probably try to draw a set of tables that are partitioned and show how there's data lineage between the partitions that are immutable, and that guarantee of using immutable data sets and consistent version jobs create an environment in which there's clarity, right? If the tables are getting pulled from under your feet, if the rug is getting pulled from under your feet, you cannot be stable and have the guarantees that you can rerun jobs. So I would say, storage is cheap. Snapshot your extracts and your dimension so you know what your user dimension looked like 90 days ago. Probably beyond that, you might have some legal issues you might have to anonymize your stuff, but keep your stuff, keep your snapshots, especially of small tables. Every time you mutate a table, you create a new partition. Same if you use files. I mean, we think in terms of Metastore and Hive and partitions, but other people think in different ways. But if you have files, every time you want to mutate a file, just don't overwrite it. Just create a new file and duplicate the data. It's fine. You'll be glad you did, especially for small tables. For large tables, then that's where you need to think about differential loads, right? A lot of people do the mistake early on of being, there's not a lot of data. I'll write a job that just scans all history and rebuilds, this fact table from scratch by scanning all my sources. Well, that's definitely that leads to n square type of problems. So you want to do differential loads and keep your stuff sane. I could talk about this stuff for a while. It's a little hard without a whiteboard, but at least I'm touching some ETL best practices. Something around scheduling too. So a lot of people that try to use Airflow early on get confused by the fact that scheduled is really built in. So we assume in Airflow that each task needs to run for each schedule. And a lot of people are like, well, I don't really care because my job reprocesses all the history, so I don't need to run every schedule. It's well, that's when you should change, and you should probably have something that's more immutable and that's more reproducible. And I think I haven't mentioned here idempotency, but having a job that you can rerun and get the same result. So idempotency means you could rerun the same job 12 times and you'll get the same result. So if it fails halfway, if you need to reprocess, data from a week ago, you can reprocess it, get the same result. So that's stuff that brings sanity to data engineers. Schedule your backfill. That's kind of a lesson out of different places, but you're always business rules always change, and people always want you to backfill everything. which doesn't scale. It's not good for your cluster. It's not good for your mental state. So you can say, this table I will backfill in a month. And if you have more business rules to squeeze in, we can alter the code logic, but we're not reprocessing everything at every change. And I guess once you get public and you get auditors, you cannot change history anyways. We're still in a place at Airbnb where we can change history, we can change our business rules, or improve them, get more accurate. But at some point, you cannot do that. I know at Facebook, for instance, beyond 90 days, we don't really touch data that's older than 90 days because we're going to predict with Facebook data that is older than 90 days anyways. So Python backend, we talk to the workers using a library called Celery. We use Flask, SQL Alchemy, some D3, some high charts that I'm probably going to rip out for the next version because I read the license and it didn't look pretty, so I think I'm going to move to a different charting library. We have a metadata database, so we use MySQL. Other people use Postgres. There's even people in production using Oracle, which I thought was interesting. And then, no judgment there. Actually, they have the judgment there. Yeah. And then if you want to know more about the dependencies, you can look at the Airflow requirements.txt in the GitHub repo. Architecture, so this one is kind of poorly designed. I just hate making these charts. It's just a lot of work, drag and dropping, all that stuff. And I'm not big on drag and drop. I prefer writing code, as you know now. It's kind of incomplete, but so this looks really complicated. You can run all of this in one box, right? It's just like kind of the subsystems, and you can scale these things out, and you can say, I want to run a worker here, a worker there, and web server can be on the same machine, or it depends on how you want to run it. You can pip install Airflow and use it, and try it and run it locally, and you don't need all of these things. I think I forgot to show the message queue. Here's a component that's missing. If you do a production deployment with multiple workers, you probably want to use Redis or RabbitMQ as the message queue that passes messages from the scheduler to the workers. We have a metadata database. I was trying to illustrate with the code repo that there's a master repo that's synchronized on all the workers and the web servers, but you can also work very nicely with your own personal code repo. So when you first author a pipeline, it's just in a local branch. And at that point in time, you can still test your code locally, assuming that you have the libraries that you need, or you can still interact with the workers and with the metadata database. And you have your own Airflow.cfg here. You can use the same infrastructure as you use for production if you like risks, like we do at Airbnb. If you don't like risk, or you work for a bank or something, or you might want to use a different, like a dev metadata database, a dev message queue, dev workers. You can do all these things. So you can organize your environment the way you want to organize it. All right, so we have a growing community. So that's the one slide about the community and the project itself, from a high-level open source project perspective. So the project is growing fast. It's only a year old. We have a lot of people that are engaged watching. We have a lot of people who are interested in this that have started the project, and we have a lot of people forking this project and playing with it. So we don't know exactly what they're doing, but it's interesting to think of what they might be doing. Here we have a lot of commits, so it's a very active project, right? If you look at Azkaban, you're probably going to see something very different. I'm not sure what Uzi looks like. One other thing that's really important about this project and any open source project is we work on the open source side of the curtain, right? So when I publish my roadmap, I do it, as a GitHub issue, and everyone can collaborate. When I think of something, I put it on the Google Groups, so people can chime in. So all of the work, all the PRs, we don't have our own Airflow repo that we bring and branch every once in a while. We just do all the work on GitHub. So I think that's pretty important. And then conclusion, next steps, right? That's always the way that people conclude. So growing a community. Yarn executors is a way for us to, instead of running on Celery workers and providing some sort of containment for our tasks. And the Hadoop community is moving towards, or is embracing Yarn despite a really bad API, apparently. but we're going to be moving in that direction too. Data lineage library. So there was this interesting project at a large blue company I worked at before that was called Data Graph, and it was a way for people to kind of suck in all the metadata from the different data systems and create a big graph. This company in particular likes graphs quite a bit, and they have, so you think of data objects. So we have really good dependency here between tasks and between tables to a certain point, but there's also a lot of data objects like report dashboards. There's people, so it's a big graph of data object, and if you can have clarity on the data lineage and who's using what, that's pretty useful. So I wanted to have a way to annotate your workflows to say, this task move data from this table to this table, or you can define your object and define the lineage between all these objects are interconnected. So yeah, I think that kind of ends this talk as far as the structured part of it, and then I'm happy to take questions and applaud.